Okay, let's try to find the interval of convergence of this series. Now here also we have to follow the same procedure. First we compute an, like from this series notation we can extract out the an term, and from that we can take the n+1 term. So after that we should get the modulus of the ratio of these two things, and then it will be something like this. So the ratio will be reduced down to n+1 divided by n times the modulus of x+2 divided by 3. And remember, n is a non-negative number, right? So like originally you will have a modulus sign for this term as well, but since this is a non-negative number, you can even write that one without the modulus, right? That's how you get a bracket for this term. And for the ratio test, when you apply this one, the ratio, you will get this one. So ultimately the limit of this ratio will be equal to the modulus of x+2 divided by 3, right? Like now in all these examples we took the ratio test, but if necessary you can even use the root test as well. Okay, keep that also in mind. And then from the results or from the conclusion of the ratio test, we can say that if this limit is less than 1, then the series converges. Limit less than 1 means this term less than 1. That means x+2 is less than, strictly less than 3. Now remember, in the previous examples what we had was something like this, right? This modulus. So when you have x minus a term, then a is our center. But when you have x plus a, that means we can rewrite it as x minus a. Okay, so minus a will be our center, right? So now don't make that mistake. Okay, now if you just consider 2 as the center of this equation, then that is wrong. Okay, so please keep that in mind. The method to extract out the center is, in order to extract out the center you need to have x minus, right? Then you can take this term as the center, but here you have x plus. So first of all you must change it to the x minus format, and then when you try to find the corresponding x values so that this inequality is satisfied, it's easy if you draw a number line and consider the distance idea. The distance from -2 should be less than 3 units. So 3 units to the left and 3 units to the right from the -2, not +2. Okay, and then so from the ratio test you can see that for all the x values inside this region, the series will converge. And then again from the ratio test you can say that if the limit is greater than 1, the series diverges. Limit greater than 1 means this greater than 1, this greater than 1 means this greater than 3. So that means the region outside this interval. Okay, and from the ratio test it doesn't say anything about the end points. So then we have to manually calculate the two end points, -5 and 1. So when you substitute -5 to the series, you will get 1/3 sigma this thing, and you can see that from the test for divergence, the limit of this term is not 0. Remember, for a given series, if the limit is not equal to 0, limit an, this is not the sequence of partial sums, this is just the sequence of the terms. If this limit is not equal to 0, then the series diverges. Okay, right. And then for the other endpoint also you can do follow a very same procedure, and then from the divergence test you can once again say that the series diverges. So in this case, for both endpoints the series diverged. So the only possible real numbers so that the series diverges is this interval, right, without the endpoints. So this is the way that we represent an endpoint, an interval without the endpoints. And if you need to include an endpoint, you just have to write down the closed bracket. Now this is an open bracket and this is the closed bracket, the square bracket, right? And here the radius of convergence is 3, because now you can see from this theorem also we have a positive number, and now from this theorem you can say that our series, this series falls under the third category, right? And there we have a positive real number so that this happens. And here you can see that the number is equal to 3, right? Okay, so from the radius, now even if we include, now say for instance, if the series converged at x equals 1, then you will get a closed bracket here, but still the radius will be the same. Okay, so radius means just the distance from the center. So no matter whether we include or exclude the endpoints, radius will be the same. Okay, right. And there is one more thing that I want to remind you. It's the way of representing or presenting the answer, right? See here, I have done all the calculations in a neat orderly manner, one after the other, without any rough work in the middle, right? So you have to keep in mind that you have to follow a very neat pattern when you are presenting your solutions, especially on exams and homework.